All right, on this question, we're going to find the average value, and we're going to do that using our formula 1 over b minus a times the integral from a to b of f of x dx. And there it is right there for you to look at. What we're going to do from here is use the antiderivative to help us with that. So that's capital F of a, capital, or b, capital F of b, minus capital F of a, which is going to be equal to the integral from a to b of little f of x dx. And remember that the little f is your derivative. Capital F is the function you took the derivative of. Okay, so that's the setup on this guy. Well, let's look at the integral then that we would get for question number 28. We're going to look at 1 over 8 minus 1 times the integral from 1 to 8 of 6x plus 1 dx. So what we have to figure out is the derivative of what function is 6x plus 1. And remember, when you take a derivative, you're subtracting 1 from the exponent. So when you go up to find that parent function, to find that original function, we're going to add 1 to the exponent. So I'm going to have something x squared and something x. And I need to be able to get 6. So 2 times what thing is going to be 6 in this case? And so that's what we have to figure out. Also, don't forget that if I've got 6x plus 1, that there's actually an x to the 0 power there. Okay? Did you figure out what times 2 is 6? It's 3, right? So my function that I'm going to evaluate, my capital F function, is 3x squared plus x. Also, don't forget that 8 minus 1 is 7. So I'm going to have 1/7 times 3x squared plus x, and I'm going to evaluate that from 1 to 8, which is going to be 1/7 times 3 times 8 squared. 3 times 8 squared. Oh, I want to put some brackets in. Okay, here we go. 3 times 8 squared plus 8. Close your parentheses, minus 3 times 1 squared plus 1. So do some math here. On the inside of all those brackets, keep that 1/7 in the front. 8 squared is 64. So I'm going to punch all this into my calculator. Give me a second to do some mathematical work and stuff. Pause, take a breath, go for yaws. Okay, here we go. 3 times 64 plus 8 is going to be 200. All right. And then 3 plus 1 is 4. So 200 minus 4 times 1/7. So that's going to end up being 196 times 1/7, which I believe comes out to be 28, but I can't swear to that. Let me see. Yes, 28. So there you go. There's your average value. All right, here's another average mean problem. There's been several of these on this test. So again, just in case you missed it the first couple times, let's talk about exactly what that looks like. And it looks like 1 over stop minus start from a to b of f of x dx. We're also going to use the antiderivative to evaluate this one because it doesn't really have a geometric shape that we can look at. And so the antiderivative, don't forget, is capital F of b minus capital F of a, which is equal to the integral from a to b of little f of x dx. And remember, little f is the derivative of capital F. So what kind of integral are we looking at over here? We're looking at the integral of 1 over pi minus 0 from 0 to pi of 3 sine x dx. All right, let's talk about this. Y prime is equal to sine x. So what does y have to be? Now think about this. Look at your trigonometric derivatives there, and you'll see that the derivative of the cosine of x is equal to negative sine x. So if I start with negative cosine x, the derivative of that would be positive sine x. And now I'm ready to go. Remember also that this 3 can come out into the front. So we're actually looking at the integral of 3 over pi minus 0 from 0 to pi of sine x dx. We just cleared up the whole sine x issue. And so this is going to be 3 over pi times negative cosine x evaluated from 0 to pi. How does that look? Let's finish the problem. 3 over pi times negative cosine of pi minus negative cosine of 0. Now this looks like a really weird thing going on down here, but this is going to be 3 over pi times, and then the cosine at pi, that's negative 1. So negative 1 is 1 minus, and then right here the cosine at 0 is 1, but that's a negative in front of it, so minus negative 1. But I've got 1 minus negative 1, and 1 minus negative 1 is 2. So this is actually going to be 3 over pi times 2, which is 6 over pi. And that's the average value for this integral from 0 to pi of 3 sine x dx. All right, last question, and we want to find the average value over the interval from 0 to pi over 3 of secant x tan x. And how do we find average value? Well, 1 over stop minus start times the integral from a to b of f of x dx. Now, this looks like a really tricky question. We got this secant x tan x here, but believe it or not, we can use the antiderivative. And so remember, if you will, the antiderivative is capital F of b times, or minus f of a from a to b of fx dx, where the capital F is the function that little f is the derivative of, okay? So here we go. The integral that I'm working with, 1 over stop pi over 3 minus 0 times the integral from 0 to pi over 3 of secant x tan x dx. All right, now you may in your mind be going, I can't find the antiderivative of secant x tan x. Well, I'll tell you what, it's easier than you think. Think about this now. Look at your trigonometric derivatives. Surely you've got a cheat sheet or you got them handy in case you don't have them memorized yet and you're looking at them. That secant x tan x lines up with something. Can you tell what it is? It's secant x. And so I can find the integral of this guy by looking at the secant, just working with secant x. So I've got 1 over pi over 3 times the secant of x evaluated from 0 to pi over 3. Now, a couple things on this one that are going to come in handy. Number one, don't forget what your fractions look like, okay? Fractions and how to do your fraction operations. For example, 1 over pi over 3 is the same thing as 3 over pi. When you divide by a fraction, you multiply by its reciprocal. That hasn't changed, okay? Well, secant x, I don't carry around in my back pocket secant x stuff, but I do carry around in my back pocket 1 over cosine x stuff. So I am going to make this one little change right here before I work out this problem, okay? Now it's easier for me to work. I know what the cosine of pi over 3 is. I struggle sometimes with the secant of pi over 3, okay? So I'm going to have 3 over pi times 1 over the cosine of pi over 3 minus 1 over the cosine of 0. And wherever this ends up should be my answer. So 1 over cosine pi over 3. Cosine pi over 3, in case we can't remember, you don't have a chart handy, pi over 3 is right here. And right here we have the coordinates 1/2 square root of 3 over 2. So the cosine is the x coordinate for that, which is 1/2. So I've got 3 over pi times 1 over 1/2 minus 1 over the cosine of 0, which is 1. So this is going to be 3 over pi. Now remember that whole multiply by the reciprocal thing. So that's going to be 1 times 2. And so this whole guy just reduces down to 3 over pi. Okay? And that's how you take the mean value of a problem. That's how you find the mean value of a problem using the antiderivative.